charge to mass ratio. See, for every charged particle, most important property is its charge to mass ratio. It was J.J. Thomson who did number of experiments to find out what exactly is the charge to mass ratio for cathode ray particles, and it was concluded that the charge to mass ratio, this E minus is called the charge and the M is called its mass, was found to be charge to mass ratio was found to be 1.7 into 10 to the power 11 coulombs per kg. This was the charge to mass ratio. We can go to the second place of decimal also, it is 1.75. Or it can be written as 1.75 into 10 to the power 8 coulombs per gram. I think you all are knowing the charge actually is expressed in the units of coulombs and mass is taken in kg or in grams. So it was this ratio which was calculated by J.J. Thomson, and later on again it was proved experimentally by Mulliken in its famous Mulliken oil drop experiment, from where he exactly calculated what exactly is the charge. So it was the Mulliken oil drop method with which he concluded that the charge on electrons is 1.6 into 10 to the power minus 19 coulombs, and it is negative. So these are negatively charged particles, and this charge of 1.6 into 10 to the power minus 19 coulombs is called 1 unit charge, and we call it minus 1 unit charge. So this is the charge. Remember again one more thing, the word electron was given by J.J. Thomson, and they were knowing that these particles of the cathode rays are negatively charged. It was proved later on by experimentation by Mulliken in his famous oil drop method experiment that the charge on the electron is this much, which is actually also called minus 1 unit. And by placing this value on this EM ratio, it was found that the mass of the electron is 9.1 into 10 to the power minus 31 kg, which in terms of atomic mass unit is very, very small. It is 1 by 1/837 of the unified mass, which is a very small number. So these are the series of experiments which have concluded all this.